Hey there, Sevens. This video is meant to help you out if you get stuck trying to read the questions and understand what things are saying. So if you're stuck anywhere here, you can find what I'm talking about that section, and I'll try to tell you what it is that we're talking about in that place. So in this first section here, I'll just read through it, and then I'll probably do this with each section, read through and then talk about them, which means you can skip forward to the part that you're stuck at. In the last lesson, you described how far apart the means of two data sets are in terms of the mean absolute deviation, which is a measure of variability. In this lesson, you'll extend that idea to informally determine when two sample means computed from random samples are far enough apart from each other to imply that population means also differ in a meaningful way. What this is saying so far is that the boys and girls had different means yesterday in how long it took them to do the puzzles, but is the difference a result of the sampling variability that we were talking about in the video earlier? Like, did we just choose people on the right and left end of the curve? Or are they actually different populations? Do boys and girls actually take different amounts of times to attack those puzzles? So recall that a meaningful difference between two means is a difference that is greater than would have been expected due to sampling variability, which is saying like sampling variability will produce some like error. Like we get some error due to this. Even here, you can see like this red mean is different than the black mean. So that's some small amount of error. It's not a concerning amount in this case, but it is error. So, so is it a sampling variability error, or are the populations actually different? Good. So now when you sign up for phones, texting is like unlimited texting for free. But when you first signed up, texting, oh, sorry, this is a different problem that I was thinking. I should read through it first. With texting becoming popular, Linda wanted to determine if middle school students memorize real words more or less easily than fake words. So you can tell these are obviously real words and these are obviously fake words. She made a list of them and handed them out and wanted to see how many people, like how could people do remembering the real words versus the fake words. Obviously real words should be easier because we have context. We've already memorized these words. So how might she have selected those 28 students? That's just random selection. You just tell me, how can we randomly select? The reason for this question is that randomness is very difficult, actually, much more difficult than you'd expect. So how can you actually ensure you'd randomly select 28 students? What do you think Linda selected? Why do you think Linda selected the students for a study randomly? Like, why is she choosing random selection? Why shouldn't she just choose the 7th grade class? And there are 28 students in the 7th graders, so she doesn't need to randomly select. Why wouldn't she just take the first 28 students she sees or whatever and select her students not randomly, but by some parameter? She gave the selected students 1 minute to memorize their lists, after which they turned their lists over, and after 2 minutes, write down all the words they could remember. Afterward, they calculated the number of correct words they were able to write down. Do you think a penalty should be given for an incorrect word written down? So given this situation, if we remember all of these, but I remember foot instead of food, is that a spelling error? Should I get a penalty, or do I just not get points? It's easier to be harsh with these words. What if I remembered all of these, but I remembered this one as CKUR? Is that the wrong word? Is it just a spelling error? Do I get a penalty? Like, if I remember funwa and I remember CKUR, do these cancel out and make that I remembered 0? Well, that's decisions that Linda would have to make. And decisions you have to respond to. So suppose the data, or the correct number of words recalled, were these. So students given the real words list remember this many. So we have some people remember a whole bunch of words. Some people remember a lot less. But with the fake words, you can just eyeball it and see this is a much lower mean. Like people are remembering less words. And that should be obvious when you look at the type of fake words we're looking at. It's harder to remember them. So good. On the same scale, draw dot plots for the two data sets. So just draw 2 dot plots here and then plot the real and fake words. Looking at the dot plots, write a few sentences comparing the distribution of the number of correctly recalled fake words from the distribution of number of correctly recalled real words versus fake words. So just in your words, describe the two distributions. In particular, comment on which type of word, if either, students recall better. Just eyeballing this, I can tell. So looking at your dot plots, it should be very, very clear which one students remember better. And describe those distributions here. Linda made the following calculations. This is great. We don't have to do mean or mean absolute deviation. She's already done it for us. So we have the good mean and mean absolute deviation. Like yesterday, you can see that mean absolute deviation is about the same for these two. In the previous lesson, you calculated the number of mean absolute deviations that separated two sample means. Use the larger to make this calculation if the two MADs were not the same. So that's just saying in this situation, we have two MADs that are similar but different. So we could use the larger one just because there's more variation in it. It's a larger number, so it describes more variation. We'd use that. How many MADs separate the mean number of real words recalled and the mean number of fake words recalled for the students in the study? So we have mean real words, mean fake words, and we have a mean absolute deviation. Use the larger one. How many deviations away are these? This is a question just like this type of one, where here the girls plus 1 mean absolute deviation equaled the boys, so that was not significantly different. The girls plus 2, or sorry, the other way, the boys plus 1 is the girls. The boys plus 2 mean absolute deviations would make the girls, so if this were a 43, we would say this one is significantly different. We would say this one could be due to sampling error. Well, here, how many mean absolute deviations fit between those two means? That's what we're asking for here. In the last lesson, our work suggested that if the number of mean absolute deviations that separate two sample means is 2 or more, then it is reasonable to conclude not only do the means differ in the samples, but the means differ in the populations as well. And that's the key, because it's the population mean we actually are trying to study. If the number of mean absolute deviations is less than 2, then you can conclude the difference in the sample means might just be sampling variability, and that there might not be a meaningful difference in the population means. So it's saying exactly this situation. 1 mean absolute deviation means that these are not significantly different. If it were 2 mean absolute deviations, then these would be significantly different. So, using these criteria, what can Linda conclude about the difference in population means based on the sample data collected? So, up here, you know how many mean absolute deviations are between. Down here, you can use this the 2 barrier to say, are the populations different or are the means different? And in the context of this problem, you're saying that do people recall fake words better than real words, or is this just a sampling problem? I mean, the difference between these. Is that just a sampling problem, or is it actually that people recall the real words better than the fake words? In example 2, so now we have a new guy, Ken. He's interested in doing a statistics study involving 6th and 11th grade students in his district. He conducted a survey of 4 numerical variables and 2 categorical variables. So numerical variables are things like the number of times you text per day or the reaction time in seconds. Those are numerical. But where is it? Oh, your ID number is categorical. Or like your name would be categorical. It puts you into a category. Your grade is categorical. So his Excel population database for the 265 6th graders and 175 11th graders has these descriptions. And I've given you this data. So we can see student ID. We can see the categorical data, like how do they get to school? What is their favorite season? I thought there was numerical data here. So I'm hoping I gave you the correct data. It should be. It is not the correct data. I will fix that and put the correct data in. So don't pay attention to this, but it should be a similar data document that you have. So he's going to go through these and do the exact same type of thing. He randomly selects students. I should be talking through. Ken decides to base his study on 20 randomly chosen people. Advise him on how to randomly sample 20 6th graders and 20 11th graders. How could he randomly sample those? Then you can see he used a random number generator. So that was his solution. He has random ID numbers. Great. For each set, find the homework hours data from the population database. So this is saying number 231, find the homework hours data. This is the wrong data, but you would go down to number 231, which I don't have. Let's say this is 231, and I would find the homework data wherever it is. Sorry, my data set's wrong. On the same scale, draw dot plots for the 2 data sets for the 6th and 11th graders. Great. From looking at your dot plots, go ahead and describe the distributions. Like how are those different? Yeah, how are the hours spent on homework different between 6th and 11th graders? Calculate the mean and the mean absolute deviation. If you're not sure about mean absolute deviation, go back to yesterday's video and I talked through it. So Ken recalled Linda suggesting that if the number of mean absolute deviations is greater than or equal to 2, it would be reasonable to think the population of 6th grade students in the district and the population of 11th grade students have different means. If the mean absolute deviations, like if the means are more than 2 mean absolute deviations apart. So what should Ken conclude? You have means here, you have mean absolute deviations here. Use the larger one of these and decide, are these the populations different or is it just the sampling that's different? And that's the end of it. Best of luck. Let me know if you have any troubles and I'll talk to you guys soon. Bye-bye, sevens.